Hey everyone, the given question is from the topic of current electricity. Right, the question is from JEE Advanced 2023, paper 1. So this is the question. In the circuit shown the figure, the capacitor C is initially uncharged. The key K is open. In this condition, a current of 1 ampere flows through the 1 ohm resistor. So we have 1 ampere current flowing through over here. The key is closed at t equals to t0. Which of the following statement is or are correct? Okay, so the value of resistance of R is equal to 3 ampere. We need to calculate that. Okay, we are going to use mesh analysis over here. All right, so let's say here current flowing is I2 and here the current flowing is I1. Okay, and we know I1 minus I2 is equals to 1 ampere. It's given, right? Current through the 1 ohm resistor is 1 ampere, right? So once we know all this, we can proceed further. Mesh analysis will give us two equations. So first of all, 15 minus I2 into R minus I2 into 1 plus I2 plus I1 minus 5 is equal to 0. So basically, I2 into 1 plus R plus minus I1, that is equals to 10. Equation number 1. Now equation number 2 is we'll do mesh analysis on the next equation. So that would imply that 5 minus I1 plus I2, right? I1 plus I2 minus 3I1 is equals to 0. So basically this whole thing I1 is minus of I1, so this is minus 1. So 5 minus 1 minus 3I1 is equals to 0. So sorry, we have I2 minus I1 equal to 0 then. I2 minus I1 equal to 1 ampere. So this would be plus 1. So we get I1 to be equal to 2 amperes. Okay. Okay, now why is it I2 minus I1 not I1 minus I2? It's because, you know, the current, well, the voltage of this guy is more than the voltage of this guy. So we have to take like that, right? So we get it as like this. Okay. We got I1 and then from here we can calculate I2. So basically I2 is from here. So from I1 is 2 amperes. That implies I2 is equals to 1 plus 2. That's 3 amperes. So 3 into 1 plus R minus 2 is equals to 12. So 12 by 3 is equal to 1 plus R. That implies R is equals to 3 ohms. So option A is correct. Now for t less than t naught means still it is open. The value of current I1 is 2 amperes. This is also correct. And as t tends to infinity, what happens is that we have voltage over here, voltage present. Okay, but the current, but the circuit is still open. Okay, so the I1 won't change, and I1 into 3 will be the voltage around this guy, and it will be vice versa, the voltage around the capacitor. I1 is 2, right? So basically the required Q is equals to C into V, that is equals to 2 microfarads into V, that is I1 into 3, that's 3 ohms, that is equals to 12 microfarads into 12 microcoulombs. So we get option D as a right answer. Now we need to see for option C, that T is equals to T naught, so T is equals to T naught plus 7.2 microsecond. At T naught, this thing starts, right? Okay. that T naught, this thing, I is equals to I naught into e to the power minus T by tau. Tau is R times C. Now we need to calculate R, and for that we are going to use Thevenin's method. Alright, what is Thevenin's method? Says that whatever you want to do, you first you open it, you take it off the thing. So when we do that, this thing is taken off, right? So this thing is open and this thing is closed right now, and we short circuit the voltage sources. So this is 3, right? So we get the net R, give our R Thevenin, let's write it, R Thevenin is equals to 3 by 2, like 1 by R. From here we'll get 3 by 2, right? And from these two we'll get 2 by 3 plus 1. So we'll get 3 by 5, right? 2 by 3 plus 1 is 3 by 5. And that are in series with this. So 3 by 5 plus 3 is 15, and that's 18 by 5. So that is your R Thevenin. Okay, I hope I'm correct. 2 by 3 plus 1 is basically 5 by 3. So R 1 by this would be 3 by 5. This whole thing is 3 by 5, and that you add 3 to it. Then no, you won't add 3 to it, right? Because this thing is open, so there is no current. There is no current flowing, right? No, we'll have to add. So 18 by 5. Okay, so we have R to be equal to 18 by 5 ohms. Now we need to calculate the net voltage around this guy. Now we have opened this thing. This is open. This is the same thing. I1 will be same. So we get our voltage to be equal to 6 ohms. Okay, right. So I naught is equals to V by R. Right. V is that. So we get 18 by 6. That's 3 by 5 amperes. Okay. So we have I naught to be equal to 3 by 5, and tau to be equal to 18 by 5 into 2 microfarads. That is 36 by 5 microseconds. Okay. Yes. 36 by 5. Which is actually 7.2. Okay. So what we get over here is that I is equals to, for this thing, the time after which the switch is open, that would basically be T minus T naught, and that would basically minus 7.2 microseconds, and tau is also 7.2 microseconds. So it is minus 1. We have I naught to be equal to 3 by 5, right? So 3 by 5 into e to the power minus 1 is 0.36. Okay, so this thing goes 0.072, 3 2s are 6, 3 7s are 0.216 amperes. So I think I made a mistake at end. So V is equals to 6 ohms. No, V is not 6 ohms. V is 6 volts. What is V? I1, which is 2 into 3. That is V. Okay, for sure. Right. That is V. Like with the voltage sources. Yeah, everything. It is V. That is 6 ohms. V by R. Oh yeah. That's here we made a mistake, right? It is V by R, not R by V, na? So V is equals to 6 by 18. This is 5. So this is 5 by 3. That's why we made a mistake. Okay. So rest all is correct. I'm really sorry for that. We have to write 5 by 3 over here. And now when you solve this thing is 0.12 and this thing is 6, right? So you have 6 as the right answer. Oh, again 0.6 as the right answer. Okay, so all the options are correct for this question. Thank you.